So we're starting our next big topic within this unit of geometric proof, and that topic is going to be the relationship between lines. And so we've got a whole bunch of definitions that we're going to talk about. We're just going to go right into them. So there's a couple different relationships that lines can have. We've obviously talked about lines that can intersect, and when they intersect they share a point. However, something else that they can do is they can be parallel to each other. So two lines are parallel when they do not intersect and are coplanar. And this is something that we generally don't really think about, is that if I just ask you what two parallel lines were, you just probably tell me that they don't intersect. But this additional part that they are coplanar is important, because I have this new definition down here, which is what skew lines are. And skew lines are two lines that do not intersect and are not coplanar. So the question is what that looks like, and we're going to take a look at an example here in a second. But we're just going to introduce our last definition, which is parallel planes. These are two planes that do not intersect. So what I'm actually going to do is I'm going to sketch a pair of parallel planes here to help us emphasize our point. So I've got a plane, and then I'm going to have another plane below it, another plane below it. That'll do. And there we go. So I've got these two planes, one's beneath the other one. And so what I'm going to take a look at here is what happens when, so if I have two lines, for example, that are both in the same plane, and they never intersect, we will call them parallel to each other. So these two green lines here, I'm trying to draw them such that they're in the same plane. However, if I were to have another line, maybe let me undo this one real quick and extend it. So if I were to have another line that were to kind of come down through this plane and then go behind it, and then go through this other plane back here, intersect it, and then go behind it, come out the other side again. So this line here, let's call it, give it a name. This is line L, this is line M, and line N. We would say that line L and line M, they intersect. However, line L does not lie in this plane, let's call this plane R, does not lie in plane R. And so line L does not intersect line N. However, they do not lie in the same plane, and there's not a plane that could contain both of them. And so what we call them, these are skew lines. So the reason for this is that, parallel lines have this unique property of, when we graph them, for example, that they have the same slope. They go off in the same direction. Skew lines do not have that. They just don't exist in the same plane and do not intersect, and so they are skewed to each other. However, lines M and N lie in the same plane. They kind of go both off in the same direction, so we call them parallel. So we have a notation for that. Whenever I have two lines that are parallel to each other, the way that I will write that is M is parallel to N. And then for these two planes down here, I can also talk about two planes being parallel as well. So this is an example of what parallel versus skew lines are. They both, neither of them intersect each other. However, parallel lines lie in the same plane, while skew lines do not. So there's just a couple different ways that lines can have relationships to each other in planes as well. So along the topic of having parallel lines, I have two postulates that we're going to throw in here. Now these two postulates are not postulates that we're going to use in proofs, but they are good things to understand. And they're just, again, these basic statements that we're not going to prove. We're just going to accept them without proof, because what you're probably going to consider that they're pretty obvious. So the parallel postulate says this, says that if there is a line and a point not on that line, then there's exactly one line through the point parallel to the given line. So what I mean by that is probably best depicted with a diagram. So if there is a line, so if I have a line here, and I have a point that is not on that line, so right here, my question is, how many lines exist that go through this point and are parallel to this line? And the answer is only one. There is only one line that goes through this point and is also parallel to this line. And so that's a parallel postulate. Parallel postulate is what it says, is that there exists only this one line. There aren't multiple here. There aren't multiple lines that can go through this point and still be parallel to this line here. One additional thing that I forgot to mention is that if I want to mark two lines as being parallel, what I will do is I will put arrows on them like this, meaning that they go in the same direction. So the perpendicular postulate is very similar to that then, and what it says is that if there's a line and a point not on the line, then there's exactly one line through the point perpendicular to the given line. And so it's basically the same thing, saying that if I have a line and I have a point that is not on the line, how many lines can I draw through this point that are perpendicular to my given line? The answer again is only one. There's only one line that exists that is perpendicular to the given line and goes through that point. Yeah, and so that's really all there is to it. Again, we're not really going to use these in proofs, but there are important things to understand. There can't be multiple lines that exist in this way. And so then the last thing that we have are one definition, and actually there's 4 more definitions that we're going to talk about, but they're going to be really hard to define with words. So the first thing is a transversal is a line that intersects 2 or more coplanar lines at different points. So what I mean by that is if I have two lines, here's one line, here is another line. The transversal is this line here that intersects both of these lines. And so a line that intersects 2 or more coplanar lines at different points. And so it intersects them at different points. One is right here, and the other one right here. So this red line here is what's called a transversal, whenever I intersect 2 different lines at different points. And so I actually create a whole bunch of angles, well, 8 of them to be exact, whenever I have this transversal. And they have some names I want to talk about. And so this is one of these things it's really hard for me to give definitions for, and so I'm just going to explain them to you using these examples. So there are 4 different types of angles that I create whenever I have these. The first one they're called corresponding angles. So corresponding angles are angles that are kind of like in the same location on this transversal, on the different lines. So each of these pairs of angles I'm going to talk about, one of them exists up here on the intersection of this top line. We'll name it. We'll call this line A and this line B. This will be T for transversal. So each of the angle pairs I'm talking about, one exists on my transversal T, but then on line A. The other one will exist on my transversal T, but on line B. So the corresponding angles in this case are the angles that are in the same positions. So in this case, like if I have the top left angles, for example, angle 1 and 5 would be a pair of corresponding angles. 2 and 6 would be a pair of corresponding angles. 4 and 8 would be a pair of corresponding angles. And then 3 and 7. They're all in these same locations on their transversals. I have corresponding angles, and then I also have alternate interior angles. And what alternate interior angles, well, we can break this down. Alternate meaning like opposite, and then interior meaning on the inside of. So they're on the inside of my 2 lines, so on the inside of A and B, so they're going to be of the set of 4, 3, 5, and 6. But they're on alternate sides of my transversal, so they're on opposite sides of my transversal. So for example, 3 and 5 are on the interior of A and B, but on opposite sides of the transversal, so they are alternate interior angles. And then 4 and 6 are on the interior of A and B, but on the opposite side of my transversal, so they are another pair of alternate interior angles. I then also have, actually that's not what I call them, they are alternate exterior angles. Alternate exterior angles. And this one, based on the previous one, I can figure out pretty easily. So alternate exterior would be on opposite sides of my transversal again, but on the exterior, on the outside of lines A and B. So I'm talking about 1, 2, 8, and 7 will be on the outsides, the exterior of A and B, and then I want the ones on alternate sides, so those pairs. So 1 and 7 would be a pair, and then 8 and 2 would be a pair. And then my last set of angles are called consecutive interior angles. So consecutive interior angles, consecutive meaning next to, and the interior meaning on the inside. So again, I'm back to this 4, 3, 5, and 6, but I want consecutive, so next to each other. So in other words, on the same side of my transversal. So in this case, those angles would be 3 and 6 and 4 and 5. So these are all my different angle pairs that get created whenever I have two lines and then a transversal intersects both of them. I create 8 of these angles here, and I have 4 different types of angle pairs. And these 4 different types of angle pairs each have an angle on one of the lines, either A and then B, and then all of them will be on this transversal. And the naming of them just corresponds to their relative location on those lines. So these are all the different definitions that we're going to be using as we move forward, talking about parallel lines. And what we're building towards is parallel lines, and then with these transversals as well, the different angles they create and the relationships between them.